Hey guys, my name is Trevor Sullivan. I'm a solutions architect with StratusGrid. StratusGrid is an AWS Premier consulting partner, and we're an independent software vendor that provides a cost optimization tool for your cloud environments called Stratosphere. If you're interested in any consulting projects, or if you're interested in cost optimizing your AWS cloud environments, feel free to reach out to us at stratusgrid.com. You can hit the Let's Talk button up here, or you can check out more information about our Stratosphere product right here. We'd love to provide a demo and talk to you about your specific use case, so feel free to reach out to us. Now, the topic for this particular video is going to be how to use Amazon Web Services, specifically EC2, with some open source software to set up your own streaming server. Now, you might already be familiar with streaming environments out there like the Twitch.tv platform, which is actually owned by Amazon. And there's also another platform that's pretty popular out there called Restream.io, and they have a free tier here, but they also do have paid pricing tiers depending on what your specific needs are as a streamer. Whether you're doing game streaming or if you're setting up a professional stream for your business, you can really use any of these platforms that you'd like to. Each of them has different pros and cons. As you can tell, the Twitch community is very game centric. Most of the shows on this platform are going to be centered around the video gaming environment. And so there's a lot of community that's just built around that on Twitch. If you're looking for something that's a little bit more generic, that's not necessarily gaming focused, the Restream platform is a great option as well. But you might not be interested in setting up accounts with Twitch or with Restream, and maybe you've already got a billing account set up with Amazon Web Services, and maybe you want to stream to a private audience. So you want to have a little bit more control over how your streaming server is set up, who has access to that streaming server, as well as the performance of the streaming server and what different video and audio bit rates are available for your streaming environment. So that brings us to the world of self-hosting software. If you're interested in setting up your own streaming server rather than using one of these managed services here, there's actually an open source platform out there that's actively being developed called Owncast. Now, the most recent release of Owncast is from April of 2024. I'm recording this in September of 2024, so it hasn't had a recent release, but there is active development going on in the GitHub repository, which is linked right up here in the top right of the Owncast website, which is at owncast.online. That's the website for this open source software here. So this is a really professional project here. They've got a great landing page here, lots of contributors to the project. There's also some companies that are backing the platform like Fastly and Docker and Rocket Chat and so on and so forth. So there is kind of this community that's emerging around self-hosting your own streaming server. Now, you could host a streaming server pretty much anywhere that you have a Linux server. It could be a virtual machine that you run at home. It could be a bare metal Linux virtual machine, a bare metal Linux machine that you run at home, or it could just be a Linux virtual machine that you run in any cloud platform, including Amazon Web Services. So, of course, in Amazon Web Services, we have the ability to spin up what's known as an EC2 instance, which is essentially allowing you to spin up a Linux virtual machine, or in some cases, you can actually spin up bare metal servers, but those are much more expensive and kind of out of scope for this particular use case here. But once you spin up one of those Linux servers, you can deploy your own self-hosted services, such as Owncast or lots of other self-hosted open source packages that are available. There's a lot of different open source software out there. If you're interested in learning more about self-hosted software, there is a list called Awesome Self-Hosted out on GitHub. So if we just do a quick search for that, there is a GitHub repository that the community kind of works on here and keeps up to date. As you can see, it's got almost 200,000 stars here. So it's a very popular project, but literally all it is a categorized list of links to different open source software projects that you can self-host on your own server. And so if I were to search for Owncast in here, sure enough, you can see that Owncast pops up right here under the media streaming category. So there's other tools that are in this space as well, but I came across Owncast and was able to set it up pretty easily. So I have had a good experience with that and wanted to show you how you can set up your own Owncast streaming server on an Amazon EC2 instance. Now, once you've set up the Owncast software on your EC2 instance, which we're going to talk about in this video from scratch, The next thing that you'll do is to install something called OBS Studio. And this is another piece of open source software that's been around for a long time. It's very prevalent in the streaming community, but OBS Studio is an application that you would run on your desktop workstation. So like my Windows 11 workstation that I'm sitting in front of now, I would install OBS Studio on my workstation, and then I can set up all of these different scenes and sources where I can, record my video, I can record my desktop, I can record a specific window on my desktop, I can add images or video files, and I can kind of mix and match those together into a scene that I want to stream or record, just like the video that I'm recording right now. I have my desktop kind of all up in here, and then I've got my video kind of down in the bottom right section of my screen here, and I'm using OBS to record this video. But you can also use OBS to do live streaming as well. So if you're interested in recording videos like what I'm doing right now, you can certainly do that. If you want to live stream, you can certainly do that. And actually a third function that I use on a very regular basis in my professional role as a solutions architect is to use the virtual webcam or virtual camera feature. So what you can actually do is set up a really advanced scene setup inside of OBS, and then you can start the virtual camera, and it actually shows up like a virtual webcam to your meeting software. So if you're using Microsoft Teams, if you're using Google Meet, if you're using Zoom, if you're using any of those platforms that uses a webcam, you can actually use OBS as a virtual webcam, and then of course just use your built-in microphone or an external microphone as your audio input for your meetings. And that gives you tons of flexibility as far as how you set up what's behind you, right? So I might have a video playing behind me that has kind of a nice professional image to it during a meeting. And so it just gives you a lot more control over your environment that you're sharing, rather than just using the built-in meeting software's kind of AI-based background replacement features that sometimes work well and sometimes don't work well. It really depends on kind of what's behind you and what your lighting environment looks like and that kind of thing. But OBS just really gives you that granular control for all three of those functions: streaming, recording, and a virtual webcam. This is awesome software. It's very high performance. It's very flexible. It gives you tons of control. It gives you a lot of control, not just over the scene that you're setting up visually, but it also gives you complex controls over recording different audio streams from different audio sources as well. So if you want to set up multiple microphones, you can do that. If you want to record your desktop audio, like from a game or something like that, you can include that as well. You can use capture cards. So I'm actually using a camera, an external camera with a capture card, a PCI Express capture card that's inside my desktop workstation in order to capture my camera externally and bring that in as a data source into my OBS Studio on my desktop system. So after you set up this Owncast media streaming software on your Linux server up in Amazon EC2, then on your desktop system or your laptop, you can go ahead and install OBS Studio. It does run on Windows, Mac OS, and Linux, so it is pretty flexible there as well. It's also very regularly updated. You can see just a few weeks ago, there was a release on August 15th. So it's really great, robust software, and I'm very thankful to the community that's building OBS for making this available, and to all of the sponsors that are making this project possible. So we're going to be kind of focusing on this whole concept of self-hosting our own media streaming server using the Owncast solution here. Now, keep in mind that Owncast, even though it is somewhat mature here, they've got a really nice website. They've got pretty decent documentation. They have a whole GitHub repository out here that you can go explore. This is an organization on GitHub, but then they have the specific Owncast repository right here. It still is preview software, though. So their current release version is 0.1.3. So they're kind of saying with that version number that it's not really production ready. There's lots of changes happening. Things are prone to break potentially. So, be patient as they are actively developing this software, because it is relatively new compared to other much more mature software solutions like OBS, for example. But we're going to be setting up Owncast, and there's lots of different ways that you can set up Owncast on your system. They have great documentation. If you go to the Quick Start tab right here, they actually have these buttons that just take you immediately to these really succinct Quick Start guides. And what we're going to be doing is spinning up a Dockerized environment. Now, if you've never used Docker before, don't be afraid of it. It's actually a very powerful and very easy to use software, but essentially what it does is it creates this isolated container with its own file system on your Linux server so that you don't have dependency conflicts between different applications. So if you're running maybe 10 or 20 different applications on the same server, it's very possible that if some of those applications share different versions of the same dependency, maybe there's multiple Python applications and they share the same Python dependency, but they need two different versions of it. You can run into dependency conflicts. And by keeping everything in its isolated container file system environment, you can ensure that those applications are not going to conflict with each other. So using Docker, even though it adds a small layer of complexity, actually makes your life a lot easier in the long run. So just bear with me as we talk through how to install the Docker engine. We're going to be using something called Docker Compose to actually have a declarative stack. And there's a very good reason for that, because as newer versions of the Owncast software become available, we simply want to be able to declare our Docker container for Owncast as a stack. And then every time that a new software version comes out, we can simply update to the latest container image and just restart that entire stack, and it'll bring up the next version of the software. So Docker Compose makes upgrading very easy because I don't have to manually recreate the container with all the correct parameters every single time, because I've already declared that inside of this Docker Compose YAML configuration file. All right, so what we're going to be doing is installing the Docker engine, installing Docker Compose, and then there is a pre-built container image available on the Docker Hub over at hub.docker.com. If you search for Owncast here, you'll see the Owncast/Owncast repository right here. And this is the container image that has lots of different available tags here, or tag versions. So we've got 0.1.3, we've got 0.1.2, 0.1.1. So every time that there's a new release, you'll have a new image version tag right here. And the name of the image is Owncast/Owncast. So that's the image that we're going to be referencing in order to deploy this container to our system. All right, so let's go ahead and get started setting things up. I'm going to assume that you already have an AWS account. If you don't, you can go ahead and just sign up for an AWS account. This probably will incur some charges, so just be aware of the pricing structure for services like Amazon EC2, as well as data egress out of the AWS platform. There is a data egress cost for any bandwidth that's sent from AWS data centers out to the internet. So that's all available on the EC2 pricing page, but do be aware that you can incur costs as a result of setting this up. So what I'm going to do for starters is make sure that I'm in a region that's somewhat local to me. So I'm just going to choose the US West 2 Oregon region right here, and I'm going to navigate to the EC2 service. Now, what we can do in EC2 is launch a Linux virtual machine, and then we can SSH into that virtual machine across the internet, and then we can get access to that VM so that we can run terminal commands to install all of the necessary software and configure things to get Owncast up and running. Now, I've already got one instance running here, and I set up a demo environment before I actually started recording this video just to make sure I was kind of familiar with everything. And that is this environment right here. And I actually set up a domain name for it called owncast.979997.xyz. That's just kind of a cheap 90-cent domain name that I purchased for kind of demonstration purposes. But as you can see, this is what the landing page for Owncast actually looks like. This is what your users are going to see when they get into the Owncast system. And then if you have an active stream going on, that video is just going to play back right here. And then it also has this administrative interface on the back end here where you can configure the server and things like that. But we need to get this up and running on a new instance right now. So that's what we're going to be taking a look at. So let's go ahead and launch a new instance here. And I'm going to show you kind of how to set things up from scratch. So I'm going to create a new server here called Trevor-Owncast-YouTube. And then I'm going to choose the latest version of Ubuntu Linux server here. I typically stick with Ubuntu server just because it's easy to use and it's very well supported. For my instance type, this is going to be one of the important things that you consider. I'm going to be using the C7A actually just a C7A large instance type, which has 2 virtual CPUs and 4 gigabytes of memory. And the reason that I'm going to be using that particular instance type is because it has enough virtual CPU capacity to actively re-encode video on the fly. As you may know, video processing is a very CPU-intensive task, or if you have access to a GPU, it can be a GPU-intensive task as well. GPUs are much more efficient at doing that. But you do want to make sure that you have a system that has enough vCPU capacity and enough RAM in order to run the Owncast software, as well as re-encoding the video on the fly as well. So that's why I'm going to be using the C7A large. You could also potentially go up to something like a C7A X large or 2X large if you wanted to. Of course, the costs are going to increase. But if you went with something like a C7A X large here, that would have 4 virtual CPUs and 8 gigs of RAM. But based on my testing, I was able to get a half decent stream quality by sticking with a C7A large. So that's what we're going to stick with for now. If you don't already have an SSH key pair to authenticate to the Linux server across the internet, you can go ahead and just create a new key pair. But because I already have a key pair set up, I'm just going to go ahead and select that here. Now, for the VPC configuration here, you should have in your AWS account something called a default VPC set up. I'm going to choose a custom VPC here that has a public subnet, basically meaning that the EC2 instance will be accessible directly across the internet. And I need that because I need to be able to SSH into that EC2 instance to manage it. And I also need the EC2 instance running Owncast to be accessible to any external users that I want to share my private Owncast server with. So that's why we need it to be publicly accessible across the internet. So I will be assigning a publicly routable IPv4 address and an IPv6 address as well. If you don't have IPv6 on your home network or your business network, that's fine. You don't need IPv6, but I'm using Starlink satellite internet and it does support IPv6. So when it's possible, I do generally prefer to kind of move towards IPv6. So I am going to select that. Now for the security group here, I'm going to create a new security group called Trevor Owncast YouTube. And we'll just give it a description here, like this security group is used for Owncast streaming servers. And I don't know why, but the EC2 console kind of has this typing lag inside of it. It's not just my computer. And then down here, we're going to leave the SSH port open. We're also going to open up some additional ports here as well. So we want to open up the TCP port 80, and I'll show you why we're going to be doing this later on, because we want to be able to have what's called a reverse proxy called Caddy, be able to provision a TLS certificate using the Let's Encrypt service. So we are going to open up port 80 as well as port 443, which is the standard HTTPS port. So I'll just open that up to all IP addresses, and we'll give that a name, HTTPS, and then HTTP up here. And then we're going to add 2 more ports. So this port is going to be the RTMP, Real-Time Media Protocol, I think it's called. And this is going to be port 1935. That's just the default number, but you can actually change that port number if you want to as well. And I'll just call this RTMP ingestion. And so this is the network port that we are going to be sending data to from our local system. So we're going to be streaming to port 1935 on the streaming server. Now, the other port that we need to open up is actually going to be the web server port for the Owncast software itself. If we take a look at the quick start guide here for using Docker, you can see that the 2 ports that are being exposed, if you just use a standard Docker run command to run a container rather than using Docker Compose, you have port 8080 that the container or application is listening on inside of the container, and you can expose it to whatever external port you want to. So I'm going to choose port 9000 just for the sake of example, but you can really map any port externally that you want to the internal application port, which is 8080. And then we're just going to map 1935 to 1935 just to keep that port number consistent. So I'm going to say take port 9000. We're going to open that up externally as well. And this will be the Owncast Owncast-Web UI. So that's for administering the server, as well as any users that want to consume the network streams. So just to review the ports really quick, we've got port 80, we've got port 443, of course, SSH port 22 as well. And then we've got 1935 for media ingestion from OBS Studio. And then we also have the web UI to manage and view the stream from Owncast. And we're going to take port 9000 and forward that to port 8080 inside the container just as a sample. But I could choose, 32,005 if I wanted to. It really doesn't matter what port you pick here. But when you actually run the container, you have to make sure that you specify what that host port is going to be that's going to forward to the container's port. So the other thing I'm going to do is just bump up my storage a little bit here since we're going to be downloading a container image with Owncast. I'm just going to make sure I have a little extra storage on my file system there. And then down under advanced details, I have an IAM instance profile set up. So this is basically an IAM role that's bound directly to the EC2 instance. And I've already set this up over in the AWS IAM service. So if you just do a search for IAM up here, you can actually go out and create an IAM role. And this is not totally necessary for this particular use case, but typically if you go over to create role, and then you say, this is for an EC2 instance, this will allow the EC2 instance to actually mount that role directly and then have access to different AWS APIs. The typical reason that I use this is for the SSM managed instance core policy, and this will allow my EC2 instance to register with another AWS service called AWS Systems Manager, and that's just kind of a backup tool for me to manage the instance if for some reason I can't SSH into the instance. So you don't have to set this up because we're probably not even going to be using this functionality, but I do typically like to have that role set up just as a backup in case for some reason I can't SSH into the instance. I can still manage it through the AWS Systems Manager service right up here. So yeah, if you search for Systems Manager, that gives you another mechanism to manage the server interactively. Now, if you are looking to save some money on your EC2 spend, you can also choose spot instances down here. So I'm going to make this a persistent request, which means that this instance is going to continue getting spun up. If I were to delete the instance, it'll just spin it up again until I actually cancel the spot request. And if it gets interrupted by another user in AWS, if they reclaim that capacity, I'm just going to stop the instance. I don't want to terminate it because then I'll lose all of the work that I've done to set up the Owncast application on that server. So if somebody else interrupts my workload, I just want to stop it. And then when that capacity becomes available again, they'll go ahead and restart it for me. All right, I think that's everything that we need to set up for our EC2 instance right here. So I'll just hit the launch instance button right down here, and that will create our EC2 instance and the VPC security group that allows access to those ports. Now it's pretty quick to spin up a new EC2 instance. So this one right here that's in the initializing phase is the one that we're spinning up. While that's spinning up, if I go over to spot requests right here and take a look at the pricing history for a C7A large, which is the 2 virtual CPUs and 4 gigs of RAM, you can actually see that the on-demand price is just around 10 cents per hour. And then the spot price is down around 5 cents per hour. It's actually less than that. It's actually more like 4 cents per hour, even down to 3.5 cents per hour. So by using the spot instances, you really can save a significant amount on your EC2 spend. Of course, with the caveat that AWS can reclaim that capacity at any time in order to accommodate other customers who are willing to pay a higher rate for that EC2 capacity. All right, so now that this server is up and running, I'm just going to grab its IPv6 address, which is right down here. So I'll just click on this button to copy that to my clipboard, and we are going to SSH into that server. We'll use the username Ubuntu because that is the default username for the Ubuntu virtual machine images or AMIs that are in Amazon EC2. And as soon as we SSH into it, we will get our bash shell on our Linux server. Now, anytime I spin up a new Linux server, I like to update the base packages. So to do that, we'll do sudo apt update and then sudo apt upgrade -- yes. And you can separate the commands by semicolons to put them all on one line if you would like to. And so this is just going to update some of the base packages that are pre-installed in the operating system, but haven't been updated in the actual base image. So that'll go ahead and install those. And then we're going to go ahead and install the Docker engine and the Docker Compose extension or plugin for Docker as well. And then we're actually going to create our Docker Compose stack file, which is basically just a YAML file that declares our container that we want to launch. So once these base packages are updated, we'll do an apt-get install on the Docker engine. And then I'm also going to search for this document called Docker Compose plugin install. And this will allow us to install the Compose plugin, which is not typically installed as part of the Docker engine installation. So it looks like this is just about done here. And Then the name of the package in apt is docker.io. So if we do a sudo apt get install docker.io -- yes, that'll install the Docker engine. And then to install Docker Compose, you see how there's a link here to Ubuntu. We actually have to register the Docker apt repositories. And so to do that, we can literally just copy this script right here as part of the Docker documentation. It's under the install Docker engine on Ubuntu. And we're just going to literally paste that script in. That will register the Docker repositories. And then we can do a sudo apt-get install on this package called Docker Compose plugin. And once that's installed, we should be able to run Docker. We actually have to add ourselves to the Docker users group. Otherwise, we'd have to do sudo docker ps. You can see there's no containers running right now because we obviously haven't run any. But if you try to run Docker PS as the Ubuntu user, you're going to get access denied. So what we're going to do is add ourselves to the Docker users group. We'll say sudo docker or sudo user mod append groups. Docker is the group we're going to append to, and we're going to append the Ubuntu user to the Docker group. So I'm going to exit and then re-SSH back into the server. If I type groups, you can see I'm now part of the Docker group here. And so now as the Ubuntu user, without typing sudo, I should be able to run Docker PS. And because I installed the Docker Compose plugin, I should be able to run Docker Compose, and I have a list of Docker Compose commands here as well. All right, so now that we've got that set up, what we can do is actually create our Docker Compose stack file, which is a YAML configuration file that's pretty easy to construct by hand. So I typically like to kind of keep things in my home directory separate. So, your home directory typically looks like this. And so any containers that I create, I like to put under a containers subdirectory. So I'll just make a containers subdirectory in my home dir, and then I'll cd into that directory. And then we'll do vim docker-compose.yaml. And you don't have to name your compose file this name, but this is the default name that Docker Compose is going to look for. So if you don't use the standardized name, then you'll have to pass an extra parameter to specify what your Docker Compose stack file name is. But I'm just going to stick with the default for now, just to make things easy. All right, so what does a compose file look like? Well, at the top, we have a list of services. Underneath that list of services, so I have 2 spaces as my indentation, I have a logical name, which is a name that I can choose, which is anything for my container that I want to spawn. And so in this case, I could call it streaming, or I could call it Owncast, or I could call it Owncast 2, or I could call it whatever I want to. I'm just going to stick with the name Owncast just because that's kind of self-explanatory here. And then under this container, this logical name, I need to specify which image I want to launch the container from. Now, of course, we already saw what this was over on the Docker Hub. It's going to be Owncast/Owncast. So we're going to go ahead and just specify that here, Owncast/Owncast latest. And by using latest here, anytime that a new version comes out, the latest tag will just point to that new version. And so we can just use the same Docker Compose stack that we're creating right now to pull the latest container image and then recreate the container without having to manually specify all these parameters that we're specifying as part of this file. So now I'm going to add another line here called volumes. And we're going to add an entry here because this is going to be an array. I'll just put a placeholder there for now. We're also going to expose 2 different ports. We're going to expose port 9000 and forward it to port 8080 inside the container for the web UI for Owncast. And then I'm going to add another entry here that's 1935 to 1935 for the RTMP ingestion port. Now let's go back to volumes here really quick. So if I take a look at the documentation here for spinning up using a container image, I can see that there's a directory inside the container's file system called /app/data, and that is where any state for the application is going to be stored on its container file system. But we want to map that outside the container. So what I'm going to do is say /, which is the current directory where the compose file exists. I'm going to refer to a directory that I have not yet created called Owncast, and I'm going to mount that to the containers /app/data file system location. So basically, when Owncast writes inside the container to /app/data, it's actually going to get written to the actual file system on the Linux virtual machine under the containers Owncast directory so that if we ever have to recreate the container, we're not going to lose all the application state. So all the configuration work that we've done on the Owncast server, we won't lose that because it'll be persisted under this mounted directory on the actual file system of the server. All right, what else do we need? So we also need to add restart. So basically, if I reboot the server, is this container going to automatically restart, or is it just going to stay in the stopped state? Well, if I reboot the server, I want the container to automatically come back online. So there is a value you can specify called unless stopped. And so if you don't manually stop the container using a docker stop command, then it's just going to restart the container when the host comes back online. You can also specify always here instead, but if you want to manually stop the container and just keep it in the stop state for some reason, then it's better to just use unless stopped, because then you can force it to stop and it'll just kind of leave it alone unless you explicitly tell it that you want it to start once again. All right, so that is pretty much all we need to do for the options here. They do also use the interactive and TTY parameters here on the Docker run command. But in this particular case, we're not going to make it interactive. I don't know why they chose to use -it there, because you're not really typing into the container. And all we need to do is to be able to examine the logs from the container, which is just standard output. So we have the ability to do that without making it interactive. So this is pretty much everything that we need. So we'll do a escape and then :WQ to exit out of Vim. And so now if we just cat to the Docker Compose file here, this is what it looks like. So now that we have the Docker Compose file created, how do we actually bring up the stack that contains the single container? Well, what we can do is just type Docker Compose up -- detach. Now, the first thing that has to happen the first time that we actually spawn this application is it has to download the container image. So that's what this step is right here. The Owncast container image is pretty small, so it's not going to take very long. But if you ever use Docker Compose to launch containers that are sourced from, multi-gigabyte container images for like machine learning or things of that nature, then it can take a few minutes for the container image to download. But again, Owncast is a pretty lightweight piece of software, so it took just a second to download that container image, extract it to the local file system, and then create a new container from that container image. So now if I do a docker ps command, you can see that despite the weird formatting here, we have a container with this ID that was launched from this container image with this entry point. So that's the binary that's actually launching it. And then these port mappings that are exposed on the system. So what I should be able to do is to hit this server on port 9000 on either IPv4 interface or IPv6 interface. And I should be able to access the application because port 9000 on the host is forwarding to the container port 8080, which is the actual application server's listening port. So what we're going to do now is take the IP address of the server. Again, you can use IPv4 or IPv6 if you have IPv6 available. Open up a new tab and plug in the IPv6 address and then do a :9000 and make sure that you put the IPv6 address in the square brackets. That's how the browser kind of interprets that that's an IPv6 address. And then I'll just put the HTTP in front there. And that should take me over to this landing page. And this is very similar to what I showed you right over here, where I had a domain mapped to the landing page on a different server that I already had set up and done a little bit of customization work on. So congratulations, you've got your own Owncast server up and running at this point. But you're probably going to ask yourself, okay, what do I do now? So how do I, configure this? How do I ingest a video? How do I change all the streaming settings and that kind of thing? Well, there is a document somewhere right over here that says Owncast is installed and I'm not sure what to do next. So I really love how easy they make this documentation. And you can say, I want to learn how to start streaming, right? And so they kind of talk you through the whole setup process here. But there is an admin interface available in here. So if you want to do any configuration, if you go to /admin in the URL, so if we just go to our URL bar and say /admin, we now are going to do basic HTTP authentication to access the interface. And again, if you take a look at the documentation right here, the default username is admin and the default password is ABC123. So we'll do admin ABC123. And now we are in the Owncast administrative interface. And so right here, it tells you how to use your broadcasting software. So, I've got OBS, which is right here. And so if I go into my settings right here and go under stream, this is the URL that I would be plugging in right here. And then I can specify a stream key, which is kind of an auto-generated password that I can use to authenticate to my streaming server, because I don't want just anybody that has my streaming URL to be able to ingest media into the server. I want to restrict who has access to it. And that's what we do with the streaming keys. So you can literally just copy the streaming URL right here and you can paste it in. And then to get a stream key, I'll just delete the one that's currently there. I can go ahead and just go to streaming keys. So that's under configuration and then server setup. And then there's a stream keys tab right here. And the default one is ABC123, but I'm going to go ahead and actually delete that one after I create another one. So I'll call this StratusGrid-key. Go ahead and add a new stream key. And now we can delete the default stream key. And so now what we are going to do is to copy that stream key, and I'm going to bring it back into OBS and just paste it in here. And sometimes it doesn't copy correctly, so I'm going to click the little eyeball there and then copy it, and then it's going to paste the full value. So there it is. So now I can apply that change, and if I click on the Start Streaming button right here, then I should be able to stream at the same time that I'm recording this video. So what I'm going to do is come over, I'm going to copy this URL, but I'm going to cut off the admin part of it and just go to the IP address port 9000. That's going to take me to the front end right here. And then I'm just going to click on Start Streaming in OBS. And after a couple of seconds, if I refresh this page right here, I should eventually see that video is being ingested. And sure enough, you can see that it changes over to a video player right here. You can see it says live for however many seconds. And if I click on play, you can actually see that I have my stream going here at the same time that I'm recording. So there's a little bit of inception going on here, but as you can see, it's literally that easy to set up in streaming ingestion using RTMP to this server. There's a lot of other things that you can customize though. So the admin password is absolutely something that you want to customize. That's one of the first things you'll want to customize aside from streaming into the server. So this is ABC123 by default. So obviously anybody who has access to your URL for your admin interface will be able to guess that just based on the documentation. So you want to override that. You can override your ports down here. Not something you generally are going to want to do, but if you do want to customize those port numbers, you certainly can. If you click on the configuration video section down here, though, this allows you to specify different quality settings for your stream output. Now, you can specify multiple variants for your stream output to accommodate users that are coming across low bandwidth connections, and you can also have a configuration for people with high quality connections that have much better bit rates, less latency, and can afford a better quality, right? So somebody that's coming across a fiber connection or maybe even a Starlink connection that has pretty good bandwidth can use that. Somebody that's coming across like a 3G or LTE connection might need a lower quality setting. So if we click on add a new variant here, I could do a high quality thing like 1080 at 60 FPS and then say 5 megabits per second. You're kind of limited on the number of characters you can have here. So just kind of keep that name as short as possible. You can increase the CPU and GPU utilization if you want to. We're not using the GPU in this case because we don't have a dedicated GPU in the C7A large instance type, but this will increase your CPU utilization. I'm just going to leave it at the medium there for now. You can also increase your bit rate. So if we want to set it to 5,000 kilobits per second, that's equivalent to 5 megabits. And then under advanced settings down here, you can specify what the resolution is going to be. So I'm going to say for this one, it's going to be 1920 by 1080. And I also want to change the frame rate up to 60 FPS so that we have a higher resolution, kind of a moderate resolution, and a high frame rate so that we get a really good experience at 5 megabits per second. Unfortunately, they do cap you at 6,000 kilobits per second. So even if you have a really fast internet connection, like a really good upload speed of maybe 50 megabits or 100 megabits per second, you can't really go past 6,000 kilobits per second or 6 megabit per second. So it would be nice in the future if for things like 4K streaming, they supported some higher bit rates, like maybe, 9 megabits is typically what I record 4K content in, or potentially even higher than that, like 15 to 20 megabits would really be a lot more ideal for 4K type of content. But at the moment, you go from 400 kilobits per second all the way up to 6,000 kilobits per second. So, at 1080, you should be able to get pretty decent quality at 5 to 6 megabits per second. It's not going to be great, but it'll be pretty darn good. So we'll go ahead and save that stream output there. And then if we wanted to, we could have like a lower quality setting here as well. We could say, maybe something like 1280 by 720. So we'll say 720 at 24 FPS, and we'll make this one like 2 megabits per second. So for the video bit rate here, I'll say, all right, I'm going to make this 2 megabits, and I'll say 1280 by 720. And for FPS, we'll just leave it at the lowest, which is 24 frames per second. So now we have these different options to choose from. So if I start streaming again right here, and you have to stop streaming and start streaming again every time that you make changes to these stream outputs right here, just so you're aware of that. If I go back to the front end right here and click on play video, you can see under this little gear icon that I have right here, I have the ability to select these different quality options. So there's the built-in one, 1.2 Mbps, 1080, and 720. Those are the two options that I set up just now. So that's how you can specify custom quality settings for your users that are viewing your streams through the Owncast software. So I really like that configuration option. There is also a chat option in the software as well, so you can have users just kind of join anonymously and chat. You can import custom emojis in here as well if you'd like to. There's also some options for things like notifications. You can set up a notification channel. You can get browser alerts to say that you've gone live as well. There's also custom integration. So one of the things I really like about Owncast is that if you want to integrate with some external system like Discord or Slack or other services in AWS, if maybe you're a developer and you want to build some custom integrations, it actually has the ability to trigger webhooks so that on certain key events, if you start streaming, if you stop streaming, if a message gets sent to your chat channel, those kind of things, then you can actually trigger different external application integrations and notify people. You could log it to a database somewhere. You can really do whatever you want with that type of data. And if you come over to the Owncast documentation here, they actually talk a little bit about what those different events are. I think that's under build on top, and then go to webhooks. And these are the different types of events that are supported by webhooks. So if somebody changes their username, if a user joins the chat, so if a new viewer kind of joins in the chat, if you change the visibility on a chat message, you can do that as well. You can actually create moderators for your channel as well. So you don't have to give them access to your streaming ingestion capability, but you can just make them chat moderators so that they can manage your chat for you as you are streaming your show. In Owncast, there's a lot of really nice features here as well. Another nice feature is that if you have a lot of streaming users, a lot of viewers, then you can actually upload your video segments or your live streaming segments up to S3 compatible object storage. So you could use providers like Backblaze or Wasabi or Amazon S3 itself, or Minio if you're self-hosting Minio. That's actually an S3 compatible storage provider as well. But what you can do is use S3 compatible storage to actually host your source files, so that rather than having everybody ingesting off of your internet connection, so if you have a 5 megabit stream, but you have 100 users, you're going to need 500 megabits of upload speed. But if you upload your stream to S3 object storage, then you can offload all the bandwidth onto that external object storage service so that you're not saturating your internet connection. You only have to send your stream out one time up to the object storage service, and then everybody else who's actually consuming the stream is actually going to grab it from the object storage service rather than hitting your Owncast server directly. So that's a really nice option as well. Of course, in this case, we're actually hosting the EC2 instance up in AWS rather than hosting a Linux server locally on my home network. So I'm still not going to be constrained by my home network's capacity, but it might be lower cost if you calculate things out. It could be potentially lower cost to provide that storage through S3 than using just basic egress through EC2. You'd have to kind of do the calculations to figure that out. I'm not entirely sure how that would work. But you can use CDN capabilities, so you could use Amazon CloudFront to provide a CDN distribution layer on top of S3. If you're using Cloudflare, they have something called Cloudflare R2 storage, which is S3 compatible storage. You could put the Cloudflare CDN in front of that as well. So a lot of different options to streamline the distribution of your video across the world to wherever your viewers are. All right, so we've got everything kind of up and running now. There are a lot of configuration options you can set here. Under general configuration, you can rename the server. You can plug in custom descriptions. If you want to do custom page content, you can do that right down here. That's what shows up on your landing page, kind of like what I have on this other sample instance right here. But one of the things that we have not yet done here is set up a domain name. So right now, I'd have to copy the IPv6 address or IPv4 publicly routable address for my EC2 instance and share that with other people. So there's got to be a better way, right? So this is where domain mapping comes into play. So what we're going to do is take our IP address of our server here. And if you've purchased a domain through a provider like Namecheap or Cloudflare or Porkbun or any of those, then you can go ahead and just set up DNS records. So in my particular case, I've gone into Namecheap here and I have set up this domain here called 979.997. It was like a 90-cent domain name that I just used for testing purposes. And I am actually hosting that DNS zone inside of Cloudflare DNS hosting. If I come down to DNS right here and go to records, I can add a new DNS record. And in the case of IPv6, we use quad A records, not A records that you use for IPv4. So in this case, because I'm using IPv6, I'll choose quad A. If you're using just traditional IPv4, you can just use the standard A record. And then for the name, I'm going to call this Owncast SG. And that'll be owncastsg.979.997.xyz. And then the IPv6 address that we're forwarding to is the IP address of the actual server. And by default, they try to enable their proxy feature here, but in this case, I'm not going to be using their proxy feature. I just want the traffic to go directly from my system directly to that server. You can also add in a note here, so they give you the ability to add a comment and say this is for Owncast on Amazon EC2 or StratusGrid YouTube. And then we'll just save that DNS record. So now to test out this record, I'm just going to copy the record name and the suffix here. I don't know if I can combine it together somewhere here. And we're going to fire up our shell once again. And in PowerShell here, I'll just do resolve DNS name. Whoops, resolve dash DNS name dash type. This is going to be a quad A record. And the name that we're going to resolve is owncastsg.979.997.xyz. And if we get a proper response here, let's run that again. You can see we get back the IP address 561B, which is the entry that we have right here. So we've successfully set up DNS. And now if I go to that address in my browser, let me just put that off to the side really quick. Now if I go to HTTP owncastsg.979.997.xyz port 9000, because we're not listening on port 80, then now you can see that I've got my stream up right here. So now the domain name works, but there's another problem. And that is that I'm not using TLS or transport layer security in order to encrypt my connection. So anybody who can intercept my network traffic is going to have the ability to potentially see my administrative password that I'm logging in with. They can see chat messages that are being sent to the streaming channel and things of that nature. So how do we fix that? Well, the way that we fix that is by using something called a reverse proxy. And there is a reverse proxy that's really easy to install and configure called Caddy. And Caddy is easy to install in Ubuntu Linux, and it's also supported as a reverse proxy very easily with Owncast. And so what they have is this little Caddy file configuration snippet. So if you just go to search docs, search for Caddy, click on the Caddy docs, and then go to run Caddy as a reverse proxy, this little snippet right here is what we can use to register a TLS certificate for the custom domain name that we have set up. So where it says owncast.mydomain.com, we're going to be using the owncastsg.xyz domain that we set up. So what we're going to do is just copy this little snippet right here. We're going to come back to our SSH session right here. And so now we're going to install Caddy. If I try to run Caddy, it actually tells you, hey, Caddy is not installed by default, right? So we have to install it, and it tells you the command that you would use to install it. So we'll say sudo apt install caddy -- yes. And this is going to install Caddy as a systemd service. So if you do systemctl status on Caddy, you can see that Caddy is actively up and running now. But what we need to do is plug in that configuration. So where do we do that? So if I hit Q there, I can do vim/etc/caddy/caddy file. And so this is the default configuration for Caddy here. And all I'm going to do is, actually I need to do a sudo. So let's do Q exclamation point, say sudo vim. We'll come down here, hit the O key to insert a new line, and we'll just paste this in. And I'll just indent these here a little bit. And I'll change the email to admin at the 979.997.xyz. And then the reverse proxy is going to be to port 9000 because that's where it's listening on the host. And then the domain here is going to be owncastsg.979.997.xyz. So now that this is set up, basically Caddy is going to attempt to register a TLS certificate using the Let's Encrypt service for this domain name. And it's going to forward traffic that comes in on this domain name for this host name. And it's going to forward it to this address, which is just the local server on port 9000. That's going to forward to port 8080 inside of the Owncast container and ultimately grant us access to the service. So let's go ahead and hit escape:WQ to save that. And now what we're going to do is to restart Caddy so it picks up on those changes. We'll do sudo systemctl restart Caddy. And then we can do a journal ctl --unit Caddy. And the unit parameter is because Caddy is a unit file in systemd. That's just how you register services or daemons in the systemd service. And so now if we take a look at the logs down here, you should see this message at the end that says certificate obtained successfully. Now, if you remember back to when we set up the VPC security group rules, we opened up port 80 and port 443. And one of those ports, I'm not sure which it is, but one of those ports is actually used to validate the DNS name, to validate that it's actually pointing at this particular server, so that when Let's Encrypt is provisioning a certificate, it has that confidence to know that that's the actual host that is requesting this particular certificate. It's kind of a validation mechanism. And so if you don't have port 80 or 443 open, then the validation process can fail and the Let's Encrypt service is not going to issue you a certificate, in which case you're not going to see certificate obtained successfully. But we are looking for that message to make sure that it is there. And you can also see that it's successful for this particular identifier. So if your Caddy file had like 10 or 20 different configurations, it's telling you specifically which host the TLS registration was actually successful for. So this is definitely good news. So now that port 443 is also open in our security group, I can simply come back to Owncast right here, and I can eliminate port 9000 because now we're actually going to Caddy. Caddy is actually intercepting the traffic, and Caddy is forwarding the traffic to port 9000. So from a browser perspective, we don't have to specify the port anymore. We're going to hit the Caddy server on the standard HTTPS port 443. If I put HTTPS prefix in here, the implied port number is as if you're doing :443, but of course, nobody actually types that these days. They just use the implicit default port. And now you can see that that is successful. So we are able to access this website securely, including the administrative interface securely. So I can just go to this URL /admin with HTTPS as a prefix. And of course I can log in here. I don't think I actually changed the password, so that's going to be the default. And if I click on this little settings icon right here, you can see it says connection is secure and it says certificate is valid. And you can see right here that it is a Let's Encrypt certificate that is provisioned to this particular domain name. So thanks to the Acme protocol and the Let's Encrypt service and Caddy open source reverse proxy software, it's very, very easy to obtain your own TLS certificate to make sure that you're hosting services directly on the internet that are secured at the transport layer. So at this point, we've pretty much got everything done. We've set up the Owncast server. It's automatically going to restart if the host restarts for some reason. And we've also set up a domain name for it to make it easy for other people to access. And we've also set up TLS encryption thanks to Caddy and Let's Encrypt and the Acme protocol. And so now we have a fully functioning streaming server here. So once again, in OBS right here, I'm going to hit the Start Streaming button once again. And we are going to come back to the front end right here. This is what your users are actually going to see. And you can see we've got this little notify option right here, and it'll prompt the browser to allow notifications. And so if your viewers want to get notified anytime that you go live, then they can allow those notifications directly through their browser, and they can just click on that and go directly to your Owncast server. But now I can click on play right here, and you can see I'm able to see myself streaming in real time as I'm recording this video. So again, a little bit of inception going on there, but you kind of get the idea of what's happening here. And again, as a user, I can come in here and say, you know what, I'm on a bad connection, so I'm going to bump down the quality settings here and just kind of figure out what I want to do from a quality standpoint. So it's nice to have the option to set up these different quality settings because it just gives you that granular control over it. You can also see that I've got this chat right over here, say hello from StratusGrid and Owncast, and there we go. So I guess my automatic name here is just Sad Beaver. So anyways, I hope you guys learned something from this video. You know, I would encourage you to go out and set up your own Owncast server, whether it's on Amazon EC2 Linux server, or even if it's on a self-hosted Linux server. Maybe you're running a Linux server on Hyper-V at home, and maybe you're running a bare metal Linux server like I do, or something of that nature. It's very easy to set up Owncast as a Docker container using either just Docker by itself, or my preference is to use Docker Compose just because we have that stack. I did want to show you one thing. If an update ever comes out for this, in my containers directory here where I have this Docker Compose file, right? I'm SSH'd into my VM. I'm in my home directory. I go to the containers subdirectory, and then what I can do is say Docker Compose pull. And what that's going to do is if there's a new tag that latest is pointing to, so latest used to point to 0.1.3, now the 0.1.4 comes out, and now the latest tag is updated to point to that 0.1.4 tag. And so when I do Docker Compose pull, that's going to simply use the tag latest to find whatever it's pointing to. And if it's pointing to a newer version, then Docker is going to download a newer version of that container image. And then I can just do a Docker Compose up -- detach. I can run that command once again if there's a new version out, and that will delete the container, but leave the directory in place for Owncast. Remember, we created this Owncast directory to store any state for the application. So it'll delete the old version of the container, it'll create a new container with the new version of the application, and it'll continue to use the configuration that's been persisted in the Owncast directory thanks to the volume mount that we created in the Docker Compose file right here. So that's kind of how that works. Docker Compose just makes it really easy to mount those directories, and you don't have to worry about specifying them again, like doing a Docker run and specify the volume mount again, and make sure you get your port mappings exactly the same. All that's been declared in this file, so all we have to do is pull the latest version and then just re-up it again, and that will take care of doing the application upgrade for us. Now, sometimes if the application has not been tested for upgrades, the application can potentially break, but I'm sure that because the Owncast developers know about that, they're probably trying to plan for that and trying to avoid any kind of issues during those types of upgrades. But I have seen some cases where the application doesn't really account for the existing state, and so something kind of breaks when you do the upgrade. So it really just kind of depends per application if the application's been designed with that type of upgrade process in mind, or if there's some kind of manual work that you actually have to do to upgrade your state folder with some newer database schema or something of that nature. So anyway, I hope you guys enjoyed this video. Thank you so much for watching. Please like this video if you learned anything new from it, or if it just sparked a new idea in your mind. Also, subscribe to our channel and leave a comment down below. That helps us to grow our channel and to bring you more great content. Thanks so much for watching, and we'll see you in the next video. Take care.